Yeah, so the first section here talking about how to find the regression equation, okay, using this formula. And to find it, you can use the calculator, or you can use the R program, and also I will show you later how to use uh, Excel. Okay. I think this one is you want to do manually. Okay. Yeah, this is the one you use R, I think. Okay. Yeah, so the next section is talking about um, regression. Okay. Sorry, correlation. The first one is a regression. The second one is talking about correlation. Okay. So correlation exists between two variables when the value of one variable are somehow associated with the value of the other variables. Okay. And in this case, we have kind of a correlation here. This we call it moderate correlation, moderate positive correlation. And this is a strong positive correlation. And this is perfect positive correlation. Like all of the data is in one line. Okay. If this one is a little bit scattered out, I mean, the data is like around uh, straight line, go to the right, from left to the right, is like move up. Okay, so this is positive. This is uh, we call it strong correlation because the data is almost located on one line. I mean, like really scattered tightly to one line. Okay. And this is negative as you go from left to the right is moved down. Okay. And this is call it no correlation if the data is scattered all over the place. Okay, so we can see the correlation will be, I mean, the linear correlation coefficient will be 0 for this. Okay, and this one is non-linear correlation because it's like kind of curve, right, or parabola. Okay. Okay, so so this is the formula to find the, we call it the coefficient correlation, linear correlation coefficient. Okay, so this, it is a number that describes the strength of the linear relationship between the two variables. Okay. Yeah, so don't worry about this formula, okay, because we just use the uh, software to find the R. So you can see here, R is always between -1 and 1. Okay. R equal to 1 means there is a perfect negative linear correlation, and R equal to 1 means there is perfect positive correlation. And the closer R is to 1 or -1, the stronger the correlation. Okay. And the closer R is to 0, the weaker the correlation. Okay. You have to be careful here. R0 does not mean there is no correlation. Okay. It just means that there is no linear correlation. There might be a very strong curve pattern. So this can be nonlinear equation. I mean, nonlinear correlation. So this is the example how to calculate the linear correlation coefficient using the statistical uh, the TI calculator. Okay. And then here I show you how to find. Okay. So this is another definition about, we call it coefficient determination. So R square. So to find the R square is just simply square the R, right? And you can see the R is, if you take the square root of, oh, yeah, so this is the formula to find the R. So Sxy divided by the square root of xxs, ssx, and ssy. Okay. Yeah, so ssxy divided by the square root of ssx ssx times ssy. Okay. Yeah, just simply you can use the yeah, so this just so remember this is R square is the coefficient of determination. Okay. What else here? Okay. Inference of linear correlation. Okay. So this is one you want to do hypothesis test also. Okay. So you can do hypothesis test for the uh, regression and correlation. Okay. So first, the same thing, like you need to set up you need to state the random variables. So the x1 is the independent variable, the y is the dependent variable. Because y is dependent on the x, so the x is independent variable, and you need to state the hypothesis test. I mean the null hypothesis and the alternative hypothesis. Okay? So you can assume the null hypothesis is r equal to 0, or there is no correlation, right? And the alternative hypothesis will be not equal to 0 or less than 0 if the correlation is negative, and the rho or the R is greater than 0 if there is a positive correlation. So you can test the claim using the next step. Okay. Yeah, so the state and check the assumption for the hypothesis test. The assumption for the hypothesis test are the same assumption for the regression and correlation. You can see this one, the assumption. And this is the way to find what is the test statistics. Right? The test statistics is using this formula. So this is equal to R divided by the square root of R minus, sorry, divided by the square root of 1 minus R squared divided by N subtract by 1, R by 2. So N subtract by 2 is equal to the degree of freedom. Okay. So don't forget to change this one as well. Want to find what is the test statistics. And the same thing, now you need to find what is the p-value, right? So if the p-value is less than, so reject less than alpha, so then you reject the null hypothesis. If the p-value is greater than n equal to alpha, then fail to reject the hypothesis. So if the p-value less than alpha, reject the hypothesis, and the conclusion or the interpretation will be uh, that either have not have enough evidence to show that alternative is true, or we do not have enough evidence to show that this alternative is true. Okay. So if the people u less than alpha, uh, the conclusion is uh, have enough evidence to show the is alternative is true. Okay. But if fail to reject, the conclusion will be do not have enough evidence to show is alternative is true. Yeah, so this is an example how to do the hypothesis test for the correlation and regression. Yeah, I will show you this in the next step. And this is we call it the standard error estimate. Okay, so let's go to the MyOpenMath, okay, and you can do this. Oh, okay. So there's another one here, and also you can find the prediction interval. Okay, so there is a formula here that you can use to find what is the confidence interval or the prediction interval. Okay. Okay, let's go to the homework here. I think I opened the chapter 10, right? Okay. Let's start with number 1. Okay, right? Yeah, so start with number 1. Right? So I will see you for number 1, chapter 10. This one, yeah. Okay. Yeah, I'll put X here so make it the chapter on the right side, not on the not in the beginning between like chapter 1 and chapter 2. Okay, so make you confused. Okay. So you have to do it in order. So you have to start from chapter 1 and then chapter 2 up to chapter 9 and then chapter 10 and chapter 11. Okay. Okay, so for this one, you're looking for calculate the correlation coefficient and round it to 3 decimal places. Okay. What you can do is just copy this. Make sure you copy all of them. First, you need highlight it, okay, and then right click, copy, and then paste it here. Okay. Put it here, right click, and then paste it. This is what, okay, let's go. Okay. And you can see our data is up to the row 14, right? So this one, so the one down here is like from the previous problem. Okay, so you have to highlight it and press the delete button to erase it, to erase them. Okay, okay, so now you need to use this formula here. Corel, array, uh, this one, and then this one. Array 1 is this data on the left, array 2 is the data on the right. Okay. So in our cases, the data is from A4 to A14, and from for the X, and then for the Y is from B4 to B14. So you have to make sure the formula here change to A4 to A14. Right? And then using the arrow button, change this one to B14. Okay, and then enter. So this will be our answer. And copy this and paste it in your answer. Okay. When you decimal in the put 3, right? So just rounding to 3 decimal, right? So it should be right there, right? Like this. Okay. Okay. This is number 1 and continue with number 2. Okay, for this one, you're looking for the recursion line formula. So the same thing, you need to copy all of this, and then go to number 2, put it here, right click, and then paste it. Right? Oh, it doesn't work. Okay. So you need to repeat it again. Okay. Put it outside here, and let me copy again. Okay, to make sure. Okay. So you can put right click and then uh, select copy. Right? So, okay, put it here, right click, paste it. Okay, this is what now. Okay. So you need to do it twice. Okay. Hopefully you only do it twice or not. Maybe. Okay. Now to find this is the slope. Okay. The number in front of x is the slope. Okay. So you can see the slope is using the data from x and b. So the x is the data for x is in. Yeah, you can. I think the order doesn't matter. Okay. You can start with the b or you can start with a. I think the order doesn't matter. Okay. So you can see the data is from A5 to, sorry, yeah, A5 to A17, right? Okay, and B5 to B17, right? So you need to put this one is A5, B5 to B17, okay? And then the same thing for the A, from A5 to A17, okay? Enter, okay? So this will be answer for the slope, for the number in front of the X, okay? And you need to put at least 2 decimal, okay? So because you say at least 2 decimal, so maybe just keep it the whole thing, okay? Now you can copy this one for the slope, and now the y-intercept, okay, of the number that is not in front of the x. Put it here, the copy paste, okay, and then check it. Okay. Calculate recursion line. Okay. So the slope is correct, but the intercept is wrong. Okay, let me see what is happening. Oh, I think I didn't change the data. See this? Okay, so you have to change the data to 17. Okay, so B5 to B17. The same thing for this one is from A5 to A17. Right? Okay. Okay, I think this now is okay, right? Yeah, so make sure you change the range of the data, right? For the slope and also for the intercept. Okay. Yeah, for this one, yeah, you know the R square, you know the R, okay? What I'm looking for here. The calculation was run to determine if there is a relationship between hours of TV watch per day X and number of sit-up a person can do Y. Okay. So use this predicted number of sit-up a person who watches 8.5 hours of TV can do. Okay. So so you know the X. So this is the how many hours for sorry, the number of sit-up is Y, right? Okay. Now you need to find what is sorry. Uh, okay, so this one is predict number of setup, and you know how. I mean, the person was the is like 8.5 hours. Okay, so that means you need to put this as X, and now you're looking for the Y in order to find what is the number of setup that person did. Okay, or will do. Okay, after he or she was 8.5 hours of taking. Okay. So let's go to number 3. So make sure you think using the formula, right? Okay. So what is the A here? The A here is negative 1.375, right? So negative 1.375, 0.375. 375, and the B the B is 27.131. 131. That's for the B. And for the R, yeah, I don't think you need to have the R. Okay, so actually you can see here, you only need the A and B and then the X here, right? Okay. So in this case, you need to replace this one here. Okay. So because 8.5, so you need to change this to 8.5. Okay. You see this is the A, right? This is the B, right? Okay. Oh, the slope is sorry. This is a slope. This is the intercept. Okay. Yeah. So this is the number that is in front of the X. Okay. So is want to answer as one decimal, so the answer will be 15.4. Yeah, okay, so the next one will be, oh, sorry. Yeah, in order to determine if it's a, yeah, so you need to find what is the array, okay. Let me go to number, what is it, yeah, number 4, okay. Yeah, put it here and right click and I paste it, okay, it's not working. So you need to try it again, okay. Okay, go back here, click outside here, click outside here, and then highlight it again, okay. And now try to paste it again. it's working now. Okay, and then make sure. Okay, so the data is covered everything, right? You can see the data is from A4 and B4 to A18 and B18, right? Okay, so make sure here B4 to B18, A4 to A18, enter. So this is the R. Okay. Yeah, automatically you find the TCV and then the RCV. Okay. Now, if the absolute value of R is greater than RCV, so the answer is yes. There is a significant correlation. Okay. And you can see here the absolute value of R is greater than RCV. So the conclusion will be yes. Okay. Oh, I think we need to change this one. So, okay. Yeah, don't forget to change this one. Okay. So this one will be from B to B18. Okay. Yeah, so the one that you need to change is this one also. Okay. And the formula for this one. Let me put the change data range, right? So you have to make sure you change the data range, okay? In order to get the correct answer. Okay. Let me put this one here. Text color. Okay. Let me put it here. So make sure that you have to change that one, right? The data range. And automatically we'll find this one, this, and this one. Okay. So, so the answer is yes. Okay. Okay. So what do you think about this? Can anyone want to try this? So what do you think? This one is just this number that says, I mean, what would you estimate the correlation coefficient to be, right? If you had this kind of scatter plot. So, so you can see from the pattern of the data, it looks like you have a straight, I mean, linear line that just goes from left to the right, move up, right? So that means the number should be positive, right? Okay. So it is not zero, it's because it's not really scattered everywhere, right? Okay. But this is a little bit scattered, so that means is the number will be this one here. Okay. And you can watch the video if you want to. Okay. I give you the example for how to determine how to estimate the correlation coefficient. Okay. So I think the answer should be this one, yeah. Because it's not really tight close together to the linear line, but it's a little bit scattered. So the answer should be 0.6 because, and also the line is look like go from the left to the right is like move up, right? Okay. Yeah, you can see this is correct answer. Okay. Okay, so for this one, simply you just take the square root of this, and to find this correlation a positive or negative, you can see from the slope. Okay, So in this case, the slope is positive. So that means the correlation also positive. Okay. So you need to take the square root of this and give you the R. Okay. So the answer should be 0. So yeah, I think this one is for number 5. I think we know number 6, right? So we need to put the R here. I mean the R squared is equal to 0.2601. 0.2601. Okay, enter. And because the gradient is positive, so this one should be positive. So that answer is 0.51. Yeah, so let me, yeah, so this is just simply looking for what is the R, right? So you just need to change it, I need to copy this and then put it in the Excel. For number 7, right click, paste it. Okay, so I think something wrong with it, right? Okay, let's see. 78, okay, 5.6. Yes, that's right, right? And then the bottom here is 69 and 46.1. Oh, up to here, okay. It's not included this one. Okay, so be careful. So you need to highlight and then press the delete button. Okay. Oh, you need to change the formula from the data is from 3 to 14. Okay. So make sure you change this from 3 to 14. From B3 to B14 and from A3 to A14. Okay. So this will give you the correct answer. So the answer is negative 0.914. Right? So don't forget to put the negative sign first. This is negative 0.914. Okay. Negative 0.914. Okay, so the next one. Yeah, for this one is simply use square it and then multiply by 100 because you're looking for the percentage, right? Okay. So number 8, you put the R here first, negative 0.896. Okay, and then enter, and automatically will calculate this one here. So this is you square it, you got this one, and then as you multiply by 100, you got this one. Okay, because you need to round up to one decimal, right? So the answer is 80.3%. Okay, yeah, so same thing, right? Just copy this and make sure the variance. Right? So someone makes up this. Okay, so and make sure you erase this one, right? Because the start from here is not the data that you have, right? You need to highlight it and then press the delete button, okay? And let it go. Okay. So you can see this is a R. So the R is from A3 to A10, and then B3 to B10, right? So this one should be 10, not 9, okay? So you need to change this to B3 to B10, and then A3 to A10, okay? Now if you square it, you got this one here. And then if you round up, if you're looking for the percentage, so multiply by 100% and round up to one decimal, so you got 10, okay? Oh, okay, so you need to put the R here. You need to put the R here. How many decimal? 3 decimal, right? So 0.316. 0.316. And this is 10, right? Okay, so easy, right? Okay. So for this one is what? So this from the left to the right. So that means the correlation is negative correlation, that's strength, right? So if the Pearson correlation is the Pearson correlation coefficient an appropriate measure of the of the strength of linear relationship for this data set? The answer is yes, right? But the negative strong linear correlation, okay? Because the line here, I mean the data is like scattered really close to a straight line, okay? Okay, so the next one, yeah, the same thing. You need to copy this and then put it in the Excel for number 11, okay? Yeah, number 10 is talking about the picture, right? Okay. Yeah, the same thing you need to put here and then right click and then paste it, right? Okay. And make sure the data is correct. So the data is up to row 18. Okay, so you need to erase the rest, right? So you can highlight it and then delete with the delete button. Okay, press the delete button. Okay, so make sure the data is up to 18. Okay. So then you change this up to 18. Okay. And this automatically calculated. This also automatically calculated because it's multiplied by R. Okay. And this score is based on A4 is up here. Okay. Based on the R. Okay. I think we already calculated this one, right? Oh, sorry. I think you need to change this one. Okay. So up to 18. Okay, so you need to change this one to also up to 18. Okay. Yeah. Fortunately, we still remember how to change this. I mean, that we need to change this one. Okay. So first, you need to find what is correlation using this data. Yes, yeah, using this data and also the command equal correl. Okay. enter, and you change this one already, right? And this automatically calculated. So this is like remember the formula from the textbook. The statistic is using this formula, right? So like oops, sorry. Yeah, so using looking for the statistic using this formula. Remember, so you have R divided by S divided by the square root of 1 minus R squared divided by n minus 2, right? Okay. So you can see here the formula is uh, yeah, I think I changed the formula here. Okay, so like I put the n is up there. Yeah, I think I changed the formula. Okay. So instead of using that one, I'm using this one. But this is like you can see here. So I flip it. Okay. So I flip it. I square it first here. This is like I'm multiplying both side with 1 minus R squared. Okay. Okay. So yeah. So when you change this one, and this one is automatically calculated. Okay. And the p value will be based on two-tailed test. Okay. Because we just need to find what is the if there is a polarization or not. Okay. So that means if R equal to 0 or not equal to 0. Right? Okay. Okay. So yeah, I think that's all right. So this is the p value. For two-tailed test will be this one. For five-tailed test will be this one. Okay. Yeah, this one should be the same. Okay. But this one is like twice. So in for decimal, the answer is be 0.001. Okay. Let's see here. Negative correlation. Okay. So that means it's a left tail test. Okay. So because negative correlation, that means it's left tail test, right? Yeah. Okay. So this is the formula that I'm using. Okay. So instead of this, the one that's in the textbook, I'm using the one in here. Okay. So actually, they are the same formula. Okay. Uh, so you just simplify it to make it like this. So you can see here the R will be this. Okay. You can copy and paste it here. And if you want to put in, do you need to run that? Please? No, you didn't need to run that. Okay. So you just keep it like that. Okay. And then the TP value is not in your calculation run both R and T as 3 decimal. Okay. So maybe you can round up to 3 decimals. So this one become like this. And then the p-value become 0.001, right? Zero point zero 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 one. Okay. And you can see the p-value is less than alpha, right? Because the p-value is 0.001 and alpha is 0.02. Right? Okay. So because less than, so the answer is let's see, I think the answer will be yeah. So the answer is because the p-value less than alpha, so the answer is there is sufficient sample evidence, okay, to support the claim. Okay, so how many more left? Yeah, I think if you can continue by yourself, okay, and we can discuss next time, okay. Okay, I think I'll give you one more example here. This is a sample that most of the students have mistake. Okay. Okay, let me go back to number 12. So for number 12, you can do is copy this and then paste it here. Yeah, so maybe I can remove that one. Okay. So because now you don't need this one here, the direction here. Yeah, what you can do is like saying you can do like this. Okay. So you can use the same data. Okay. Then maybe I just keep it over there. Okay. So now make sure the data is from A4 to A18. This is the one with the outlier. Okay. The one with the outlier, you need to go from P4 to P18, right? So it is okay, right? Now without the outlier, you have to make sure uh, you up to the A17 and also P17, okay? Because the outliers is the one in the row 18, okay? So this will be answer for this one. This with outlier. And then you need to put in this. Yeah, so now you need to copy the one without outlier, okay? This one here. Okay, so put it there. And you can compare between these two, right? One is like has negative correlation, and the other one is like have positive correlation. But the numbers is really close. Both of these numbers are really close to zero. So what I mean is, uh, what is what I mean? Would inclusion of the outlier change the evidence for or against the significant linear correlation? So I think the answer is no, right? Because both of them is not really different, right? So only different is only the, yeah, in terms of the number, I think they are close, right? Okay, this one is like close to one. I mean, it is close to 0.2. And also this one is like close to 0.2, and both of them like close to zero. Right? So both of the data will be scattered all over the place, right? So I think the answer is no. Okay, okay, does it make sense? You can see if you round up to one decimal, this equal to 0.2, but it's negative. And also this one is like close to 0.2 if you round up to one decimal, right? But both of them is close to zero, right? So that means the inclusion of the outlier does not change the evidence for a significant correlation, right? Okay. Okay, I think that's all, okay, for today. So you can continue by yourself. Okay, let me give you another example here. Okay. So this one is a little bit different. Okay. So in this case, you need to find what is the x if you know the y here. Okay. Because 60 is the response variable, okay, or the y. Okay. You need to solve this equation to for x, right? So that means you need to subtract y with this and then divide by this, right? Okay. You can see in the formula here, it's like the response variable subtract with the intercept and then divide by the slope, right? Okay. Let's see here. Number 13. Okay. So I already put the formula here. Okay. You just need to change this variable. Okay. So in this case, the y is 60, right? 60. Okay. So the y is 60, and then the m is negative 0.342. And then b equal to, this is on the right side, positive 14.048. Okay. So I already put the formula here. So this is like the y, start with the b, right? And then divide by the slope. The slope is the slope is I5, right? Okay. And the y is T5, and then the b is K5, right? Then divide by the slope is A5. So this will be answer for the x. Okay. Uh, yeah. And you need to round up to one decimal. So this will be 4, right? Oh, yes. Hmm, this is not- okay, here. Yeah, so you can continue the rest, right? So you need to answer 6 more problems, right? So you can, so this is 14. Yeah, I think I'll give you the formula there so you can, um, yeah, also, yeah, wait, make sure you change the data here, okay? So this is the value, the one that's in here, okay? And then the end using the formula. So we'll make sure the data from 83 to 822, right? Okay, so this is 82, 822, right? Okay, so that's correct. But I think this one should be 62.9, right? This one should be 62.9. 62.9. Okay, yeah, I think this is correct. Okay, so the answer will be this one here. If you want to put in partition also, this is the number that you put there. Yeah, so that number 14 and then number 15, this one. Yeah, so make sure this one will be the y here, okay? And this is the n. That's to be in the problem, right? Yeah, it give you the m is to be the number in front of the x, okay? So then this is the b, right? When you change that, and automatically you will give you the answer. Okay? So here you need the m, you need the b, and then you need the x. The x is from this, the x from, I think to be on the left, from the left side. Yeah. Okay, see. Yeah, maybe I need to change this one. Okay, so you can see on the one on the right side over there. Maybe I need to cut off from. mm, Yeah, let me cut off from here. Okay? And then put it on here. Yeah, I can insert the space here. You can see now this is the x. Okay? So this numbers, so the number down here should be, okay, so this is the m, so the m should be, okay, maybe I need to fix this, okay, what I'm gonna fix it is this one, okay, so the x is, I mean, the m is 1.445. 1.445 x, and then the p is plus 4105. 4.105. So 4.105. So this one will be 1.445, right? And the B is 4.145. And the X will be, okay. Yeah, I think I will change the N will be the one that you have here, 95, right? Okay, so let me put this on. And the X bar is 57.1. 57.1. And the Y bar is 76.6. 76.6. Okay, so in this case, the R is, what do you have here? 0.067. 0.067. 0.067. Okay. And this is 100, right? So this is 100. 600. Okay, so so this is correct. M is positive, right? And then the P is positive, and this is the X is 100. And the Y should be this equation. Okay. Oh, okay, I think again this is something is up the formula. Okay, so this one is to be equal to, you know, okay. Okay, so you can see here, the R here is close to 0 because the R is equal to 0.067, right? Okay, so that means it's like almost no correlation, or the correlation actually really big. Okay, so the predicted value will be, you can use the the Y bar. Okay, so you can use the Y bar here. So the predicted value will be 76.6. Okay, so instead of using the Y here, so okay, let's see here. Yeah, if not, you can use this formula. Okay, so that's it, this one. But if the R is not close to 0, you can use this one here. Okay, but what is close to zero, you can use the mean of the y or the predicted variable. Okay, so the answer here will be 76.6. Okay. Yeah, I think that's all. Okay, so I believe this. You just continue with this. Yeah, I think for the rest, I think you will be okay. So yeah, so for this one, because this is scattered all over the place, but look like good like this, so the answer is negative. Okay, so which one is the sum of the negative that is equal to zero? I think that should be this one, right? Okay, so this is the A. It is a negative, but it's close to one, so which is this one, right? Okay, this will be B, and this one is close to one, but it's positive, so will be D. Okay, so this is D, but this is close to one, but it's close to the right, so that means is the number that is close to one. I mean that's equals to zero, but positive. Okay, so will be C. Yeah. Yeah. So this is something you need to use the data to find the slope and to find uh, the slope, right? Okay. But let me make sure this data is correct. Okay. So this is number 19, right? So the data is from 6 to 9, right? I mean 6 to 91. Okay. Yes. Okay. So I believe this is correct. Okay. I mean the Excel is correct. No problem. Okay, so yeah, I think no one change this one. Yeah, I think this one should be 30, right? Okay. That number, yeah. Okay. So if this is negative, so this the number in front of the x is the slope, right? So and then negative is equal to negative. Okay, so yeah. So any question? Yeah, make sure you go to the weekly chapter, okay? So under you need to go to here and click button.